and welcome back to the Advanced Algorithm playlist. I am Sahil Sawant and in today's lecture we are going to dive deep into most intuitive and visually appealing ways to solve recurrences, that is the recursion tree method. अगर आपको ड्राई मैथमेटिकल स्टेप्स बोरिंग लगते हैं, डोंट वरी. Recursion tree is super visual and super easy and very logical way to solve recurrence relations. Here's what we are going to cover in today's lecture. So first is what is exactly recursion tree, how to expand recursions visually, how to calculate the work at each and every level, how to find total work, that is the sum of all the levels, fully understand examples and its real life analogies to maintain and build the intuition to you guys. So without further ado, let's dive deep into the topic. Whenever you write a recursive algorithm, the function keeps calling smaller and smaller version of itself. A recursion tree is a diagram that shows these calls like a family tree, but instead of children, we have subproblems. Imagining it with real life analogy, take an example of big jigsaw puzzle. You can call two friends to help you. Each of them again call two people again. This becomes a helping tree. At each level, more people join in, but each person solves a smaller piece. Similarly, in recursion tree, root is the original problem. The level 1 becomes the first part of the sub-problem. The level 2 becomes the second part of the sub-problem. And this continues on until we get the smallest base case. This tree structure helps us calculate the total work done by an algorithm. So let's draw the most famous recurrences in algorithm. T of n equals 2 times of T of n by 2 plus n. This is the recurrence relation for merge sort. So the step 1 is going to be drawing the root. The root has the cost, that is n. Now in step 2 we expand. At the next level, that is level 1, we call two sub-problems each of size n by 2. Each contributes n by 2, so the level is going to be 2 times of n by 2 and the total cost of level remains the same, that is n itself. Now in step 3 we expand again, which gives us 4 sub-problems in total. Each sub-problem costs n by 4 amount of work and the total work contribution is always going to remain as n itself. In step 4, continue with the same type of problems. Step 5, keep on dividing by 2. This gives us the total levels. And in step 6, we get total work, that is equal to cost per level multiplied by number of levels. So to find number of levels, we get number of levels as log n and cost per level is going to stay as n itself. So by this relation, we get T of n as theta of n log n. देखा, अब बड़े आराम से एक विजुअल ट्री के रिजल्ट से हमें रिकरेंस रिलेशन का सॉल्यूशन मिल जाता है. सो नो नीड टू पैनिक विथ सब्स्टिट्यूशंस और मास्टर थ्योरम्स. Imagine you are organizing a birthday party, okay? You have n tasks, you divide them among two friends, each friend does n by 2 amount of task. Then each of them assign 2 new friends, which each of them do n by 4 amount of task. Now the total task done by everyone remains is going to be n itself. At every level, total work, that is the task done, remains n. You stop it when the tasks become atomic. So the total effort becomes n times of log n. This exactly is what the merge sort algorithm does. Moving on to the next example, that is T of n equals T of n by 2 plus n square. Now this is a different kind of recursion relation where the root cost is n square. For the next level, it is going to be n by 2 square, which is n square by 4. In the next level, it is going to be n by 4 square, that is n square by 16. Now this we can observe it as a geometric series, n square plus n square by 4 plus n square by 16, and it goes on so on. So in this case, T of n is going to be theta of n square. Notice something, even though there are recursive calls, most of the work happens only on the top level. The lower levels shrink too fast. Moving on to the next subproblem. Now the next example is t of n equals 3 times of t of n by 2 plus n. This recursion relation appears in divide and conquer algorithms like ternary merges. Let's build the tree. So the cost for level 0 is going to be n. In level 1, it is divided into 3 subproblems, each of size n by 2. So the total cost is going to be 3 times of n by 2, that is 1.5 times of n. In the next level, that is level 2, it is going to be divided into 9 problems and cost of each subproblem is going to be n by 4. So the total cost is going to be 9 times of n by 4, that is 2.25 n. In level 3, we get 27 subproblems and the cost is going to be 27 times of n by 8, that is 3.375 n. We see the cost is growing like n into 3 by 2 to the power k. We stop at level log of n. Total is going to be n times of sigma 3 by 2 to the power k. This is a geometric sum. So t of n gives us n times of 3 by 2 to the power log of n. As we convert the bases, 3 by 2 to the power log n gives us n to the power log of 3 by 2. After simplification, the answer becomes t of n equals to theta times of n to the power 3 to the base 2. That is theta of n to the power 1.58. This shows how recursion tree can give intuition about growth as well. Many students may ask, sir substitution और मास्टर्स थ्योरम से भी सॉल्व होता है, फिर रिकर्जन ट्री ही क्यों? So the answer is simple. It gives visual intuition. You can understand how the work is being distributed. You can guess growth even without formulas, and it builds understanding of divide and conquer patterns. Algorithms may be predictable, but they are not scary. For exam preparation or coding interviews, always draw the first 2 to 3 levels. Look for the pattern in level cost. Find the height of the tree, multiply them or find the geometric series, and that's all. Thank you so much for watching the lecture of Advanced Algorithm playlist. If you like my teaching style, simple, clear, thoda sa Hindi, thoda sa fun, make sure you like, comment and subscribe. In next lecture, we will be looking at master theorem, the shortcut to solve recurrence functions. मिलते हैं next video में. Until then, adios.